Hey guys, so in the last lecture, we have started a new topic in ocean energy chapter, it is tidal energy. So, in tidal energy, we have seen that various high tides and low tides during the various seasons of the moon due to the attraction of the moon and sun. So we get high tides and low tides. So in a full lunar day, there are two total cycles in which you get two high tides and two low tides. So we also seen a whole lunar month how we get high and low tides. So then we have seen that the tide power is directly proportional to the range square. So that we have seen uh, with the help of tidal power in a single basin system. So in this single basin system, we got the formula that power P average upon area A is equal to 0.225 R square watts. So uh, num- like, based on this numerical, based on this equation, we will solve one example which was asked in GTU. So, so this is an example: a tidal power plant of single basin system has a basin area of 25 into 10 raised to 6 meters square. So area is given. The tide has a range of 10 meter. So R is given. The turbine however stops operating when the head on it falls below 2 meter. So that is small r is given. To calculate the energy generated in one filling process in kilowatt hour, if the turbine generator efficiency is 75% and density of water is 1025 kg per meter cube. So let's list out the data. Area is 25 into 10 is to 6 meter square. Then range R is 10 meter. Then the turbine stops operating when the head when it falls from 2 meter. So 2 meter is the head. Then calculate the energy required in one filling process in kilowatt hour. So how much energy is required in kilowatt hour if the turbine efficiency is 75% and density of water is 1025 kg per meter cube. So the total theoretical work W will be equal to from capital R range to where the turbine stops working is minus rho GA into HDH. So this will be equal to 1 by 2 rho GA R square minus R square. So the average power so the average power will be work done upon time. So that is, as we know, that is rho g a r square minus r square upon 2 into 22350. So average power will be 1025 into 9.81 into 25 into 10 raised to 6 into 10 square minus 2 square divided by 2 into 22350. So the average power P average will be equal to 1943.568 into 10 raised to 6 kilowatt hour. So considering the turbine generator efficiency of 75%, so P actual will be into 0.75, so will be 1457.676 into 10 raised to 6 kilowatt hour. So this is the power which is required for filling process. So now you will see various types of tidal power plants. So which are the various tidal power plants which we can install to get this energy from the tides? So to utilize the tidal energy, water must be trapped at a high tide behind a dam or barrage and then made to drive the turbine as it returns to sea during low tides. So the available energy in proportional to the square of the amplitude. So the main components of this tidal power plant are first dam, then second sluice ways, and third powerhouse. So the function of the dam is to form a barrier between sea and the basin or between one basin to another basin in case of multiple basin, and the most suitable word for the tidal power plant is barrage. So barrages have to resist waves whose shock can be served and where pressure changes continuously. The second component of tidal power plant is sluice ways. So the sluice ways are gates control devices. So they are used to fill the basin during high tide or empty the basin during low tide. So in existing plants, vertical lift gates have been used. Sledge gates can also be used. The flap gates allow only in one direction of the sea to basin, therefore the level of basin rises. The third component is powerhouse. So in powerhouse, turbine, generator and auxiliary equipments are the main components of this powerhouse. So that is turbine, generator and auxiliary equipments. Large size turbines are used because of low head available. Kaplan turbine with variable pitch blades, bulb type turbine or rib type turbines are more commonly used. Tidal power plants are classified on the basis of basins used for power generation. So there are only two types of uh, basins, that is first single basin system and second double basin system. So we will see one by one both. So let's start with single basin system. So first single basin system. So this is the simplest system to generate tidal power, and the single basin scheme have only one basin. So the basin is separated from the sea by a dam. So the sluice way is opened during high tide to fill the basin, and the turbine generator units are mounted within the ducts inside the barrage. And the single basin operation of tidal power plant will show in this in following the figures. So the single basin system can be classified into three system. That is, first is so we will just draw the plan. So suppose tidal plant tidal plant operation. Sluice ways, turbines, this is suppose C, this is basin, this is sluice ways, this is turbines. So suppose now we construct a dam. So this is the plan, this is the top view. So now let's uh, see the front view. So suppose this is a dam. So suppose this is the high tide, this is C, this is high tide, and suppose this is reservoir filling. Reservoir filling. Now suppose we have a low tide, that is ebb tide. So in that case, so the sea is filled from the reservoir back. So in that case, what will happen? So similarly, we are drawing the diagram. So there's a dam. So if there's a low tide and the reservoir is full filled, so the water will move from reservoir to the sea. Same diagram. So this is low tide or ebb tide. This is sea, reservoir emptying. So sluice gates a shut turbine operation section. So when the flood tide, that is high tide, comes in, the sluice gates are opened to permit the sea water to enter the basin or reservoir, while the turbine sets are shut. The reservoir thus starts filling while its level rises till maximum tide level is reached. At the beginning of the ebb tide, the sluice gates are closed. Then the generation of power takes place when the sea is ebbing, flowing back to the tide, and the water from the basin flows over the turbines into the lower level of seawater. So the turbine are keep working until the rising level of the next flood tide, and the falling reservoir level together reduces the effective head on a turbine to the extent where it can no longer work safely and efficiently. The turbine are then closed and the sluice gate opened again to repeat the cycle of operation. So this is how the tidal power generation works. During high tide, reservoir is filled. During low tide, the reservoir is being emptied. So during the low tide, the turbine is being rotated. So this was the first single ebb cycle system. So now we will see the second single tide cycle system. So in the single tide cycle system, the generation, so in single tide cycle system, the generation is affected when the sea is at flood tide. So here as we can see that the generation was done at the ebb tide, but here the generation will happen at the flood tide, that is high tide. So the water of the sea is admitted into basin over the turbines. As the flood tide period is over and the sea level starts falling again, the generation is stopped. The basin is drained into the sea through its sluice ways. The ebb tide has a long duration than flood tide. The ebb operation provides an increased period of actual work. So it has been estimated that energy produced by an system, ebb cycle system can be as much as 1.5 times the tide cycle system. The tide cycle requires a deep reservoir, thus it requires greater construction costs. The main disadvantage in both ebb cycle as well as tide cycle is the intermittent nature of operation. So generally ebb cycle is preferred than the tide cycle. So this cycle is not preferred. So now we will move towards the double cycle system where at the both ebb and tide power has been generated. So that is third double cycle system. So in double cycle system, the reservoir turbines are installed and power is generated during filling and emptying the basin. So the filling process occurs when the ocean is at high tide and while the water is in the basin is at low tide. So the emptying when the ocean is at low tide and the basin as a high tide, the flow water in both direction is used to derive the reversible turbines. Each turbine drives the generator into this system. And also, continuous generation of power is not possible because short duration interruptions in the turbine process. So, electric power is generated during two short periods during the tidal period of 12 hours and 25 minutes, or once every 6 hours and 12.5 minutes. So the working has been explained of the double cycle where the both high tide and low tide power has been generated. So this was the single basin system. So in that we have seen different categories of cycle, that is single ebb cycle, single tide cycle, and double cycle system. So in the next lecture we will see double basin system and various site requirements for tidal power plant. So hope to see you in the next lecture. So thank you very much.